Assalamualaikum and a very warm welcome to all who's watching this video. My name is Aqil bin Anas and accompanying me, Muhammad Anas bin Nazmi and Muhammad Hamirul Hisyam. All of us will be presenting regarding on topic 1 for our course, which is QCB4233 Key and Rock Physics. So today, I will be talking about time-depth conversions. Depth conversion is the process by which interpreted seismic horizons and time domain seismic itself are converted from time travel time domain to the depth domain. Predicted depth surface of these types are usually used for multiple purposes, including drilling prognosis, in-place hydrocarbon volume estimation, and also reservoir modeling. To convert time reflections to a depth surface, we need to know the velocity. So in a simple equation, depth equals velocity times time. For depth conversion, velocity varies with rock type, depth of burial, and also pore space such as porosity and the presence of microfractures. So now let's talk about the workflow for depth conversion. So first and foremost, what we must do is that we must right click the check shot options sets on the sidebar and click edit. As edit, check shot sets window pop up. Now click on create new check shot sets. Now you can change the name of the well from new set to demo well or any other name, doesn't matter. Now click on read ASCII file. Now from the pop-up window, uh, click select on read depth meters to time two-way times in meter per second, and then select check shot information to be imported into text format. Now we need to specify the column number and units of data to be read as column information. Then we import the check shot data. The imported check shot data will be shown, and finally to activate the data, we need to toggle the active button to ensure the imported check shots are active. Now, let's continue on to the results. So based on the result is a composite line through 4 of 9 wells which are used for seismic volume depth conversion, where A is the initial and B is the final. So as you can see from the result, there is a dish shape. The depth markers are represented by the dish shape, which are also the same color as the horizons. As you can see from when we try to correlate A and B, you can see that the depth markers of B is actually on the horizon while A is not. So meaning this section has it has been converted to depth. Now, based on my experience, depth conversion is a simple and fast method to perform final time to depth conversion. The inversion is not able to minimize only the vertical misties between the wells and seismic data, but also the travel time errors at all offsets in a common image gathers as well. Now, I would like to pass the floor to Hamirul Hisyam to continue on with the presentation. Thank you.
Hello, my name is Muhamad Hamirul and I will talk about the mineral and volume set calculation. For the intro, there are two minerals that are used for this calculation, which is the shale and quartz. Quartz can represent the mineral from the reservoir, while the shale for the seal. Tin sand, which has the quartz mineral, can indicate that it's a good reservoir. Radar software can be used to calculate the mineral and volume set by inserting the desired input, such as the ray deflection. When the detail of information of minerals material are not available, simple mineral information are extracted from the well and log by simple clay volume analysis. In this case, we assume there are only two minerals that are which are the quartz and clay. For the workflow, we start with the in-well view window. We right click on the volume log track, then we add volume set to track. Then we select volume fraction set, create the new volume set, then rename it. Then we add the volume log, then we select the V shale GR, and then we choose the shale and we click OK. Then we create the complement log, we choose quartz and click OK. And the last one is the final view of the select volume fraction set window after shale and quartz has been specified. Then we click the OK. So this is the result for the mineral and volume calculation. This picture shows the window with volume fraction sets. The green one represent the shale, while the yellow one represent the quartz, which is the greens from the left and the yellow from the right. For the last one, for my part, is the experience that I get from this class. First, I get to know the new knowledge about the software that has been related to the industry, which is RockDoc, that's been in this lab. Then I can apply the knowledge that I have learned in the class into the lab session. Then this lab is a bit challenging because I need to start from zero experience and zero knowledge, and many staff have been involved in this lab. We have on the RockDoc, we have the SG, and the last one is I'm proud to end this lab session with the new experience and knowledge that I can apply in the future. Thank you from me.
Okay, now I will proceed with the last part of this topic, which is the VP, VS, and density log prediction by using the rock dot. So a little bit introduction about the VP, VS, and log prediction. So compressional velocity, VP, shear velocity, VS, and the density, rho, are very important for hydrocarbon reservoir characterization. This is because it's important in the inversion part where we are using all of these parameters to obtain the reservoir characteristic such as the bulk modulus, shear modulus, Young modulus, and also the Poisson ratio to characterize the reservoir and obtain the information about the different lithology in our reservoir. Now, we proceed with the workflow of the VP, VS, and also the density log prediction in the rock dot. Firstly, we need to go to the well viewer window, and we need to choose the well ops. And then we will go to the log prediction and we choose what type of log that we want to predict. For this workflow, I choose the how to predict the VS log. So after that, we go to the tab of the prediction tab, and we need to choose the VP log that are already in our well, and it will be used for the prediction soon. So after that, we need to highlight and select the VP log that we have in our well, and then we also after that we choose the empirical method that we want to calculate the VS after this. So in this workflow, we choose Greenberg-Castagna for the calculation, and we just click the calculate, and then we put the suffix name, which is the VS name, to save as a new log in our well, and it will appear in our well, and it will be discussed in the result after this. So this is the result, and after we save the VS log, it will appear in our track, and the red color one indicate that it is not been saved yet, so we need to save the log for our reference. So as experience that I get from this lab is the first one is to familiarize with the current software used in this industry, which is the oil and gas industry use this rock dog for the reservoir characterization and well logging. Then I learned the theory and I can practice in the class what I learned from this rock physics and also the QI. And the third one, during my first time using this rock dog software, I experienced some difficulties. But when going through the software, it become more smoother. And the last one, the software skill can be applied when working in the same field, which is the rock physics and also the reservoir characterization study. So as the conclusion for this topic and also this lab, the first one is the software skill for the well log and reservoir characterization is important in the part of reservoir interpretation. Next, the utilization of latest software in the lab is an addition skill to the student before entering the current industry, that we need to have the software skill before we go in the current field of studies, also the working experience in the future. And the last one, basic theory and knowledge in the QI and rock physics can improve the understanding on how the software working. So from this lab, we know that we learn about the theory of the QI and rock physics, and then from this software, we can apply it and see what the outcome from the what we learn from the such as the calculation and also the prediction of the log, which is in this topic, the VP, VS, and also the density log prediction. So that's all from us. Thank you for your listening.